Hi, and welcome to week 4, the anatomy of the ear. In this week, we're going to go through one of the other basics that we need to understand about hearing and its impact on speech and language development. As an overview, I want you to become familiar with the structures of the human ear. On this page, you're going to see the vocabulary that you need to become familiar with. As you study more about the human ear, you'll discover that several of the parts that we're going to talk about also have synonyms that we refer to. For example, the outer ear is sometimes called the auricle, and we also call it the pinna. In the middle of the page, you'll see the word malleus, and that's one of the bones of the the middle ear, and that's also called the hammer. And those are just some examples. So as we go through, I will interchangeably use these terminologies so that you become more familiar with them. What I want you to see from this slide is the 3 brackets at the bottom that talk about the 3 main parts of the ear: the external or outer ear, the middle ear, and the inner ear. We're going to talk about each of these pieces as we move forward. On this slide, it gives a pretty good outline of the structures of each of the parts of the ear. It also starts to introduce you to some of those synonyms like I explained in the first slide. If you look in the middle of the page, you'll see the sentence that says, attached to the other side of the eardrum in a small space of air are 3 tiny bones or ossicles, the malleus, the incus, and the stapes. And then in parentheses, you'll see or hammer, anvil, and stirrup. Those are synonyms for the terms malleus, incus, and stapes. So those are your first 3 examples of how we use synonyms to talk about the same parts in the ear. The outer ear, we'll start there, is the first of the 3 main parts of the ear. It's made up of 2 sections, the pinna or auricle and the external ear canal or external auditory meatus. Its purpose is to localize sound. It directs sound from our environment into the ear. Think of it like a funnel where it funnels sound, just as you might funnel liquid into a large bottle, or the neck of a bottle. You funnel sound into a narrow canal known as the external ear canal. This leads to the middle ear. The middle ear's border guard is the eardrum or the tympanic membrane. Those again are synonyms. The job of the tympanic membrane is to keep dirt, fluid from the middle ear, but also to create a means by which you take the sound waves and start moving that sound wave to mechanical energy. It is the beginning of the middle ear. The other components of the middle ear are the malleus, the incus, and the stapes, and the eustachian tube. All of these are contained within what we call the tympanic cavity. The tympanic cavity is a space of air that is between the eardrum and the inner ear. So the sound waves arrive at the eardrum vibrates, which moves the malleus and the incus and the stapes. Think of a mechanical part, like in an engine, where one part moves the other, and that's what happens here with these 3 bones. The malleus is also called the hammer, the incus is called the anvil, and the stapes is called the stirrup. These 3 bones move, changing the sound waves to mechanical energy. At the base of the stirrup is an oval piece of bone. That piece of bone attaches to the oval window, which is the entrance to the inner ear. The one part we haven't yet discussed is the eustachian tube. The eustachian tube's job is to aerate or ventilate the tympanic cavity, keeping the bones dry. So what happens? Sound waves enter the pinna, are gathered by the pinna. They enter the auditory canal. Those sound waves strike the eardrum. It makes it vibrate. Those sound waves move through the ossicles, which create a mechanical energy movement. Those get attached to the inner ear by the oval window. The stirrup vibrates, and that vibration sets the fluid in motion that is a part of the cochlea or inner ear. The fluid changes the mechanical energy to hydraulic energy. The cochlea contains hair cells. Those hair cells are moved by the fluid, which again turns it into electrical energy or nerve energy. It is sent to the auditory nerve, and that electrical impulse is then sent to the brain and interpreted there. You can read more at this link, but that's a pretty brief, pretty basic explanation of how that might work. So let's talk about the inner ear, the last of the three main components. This is made up of this vestibular labyrinth, the cochlea. The vestibular labyrinth has the semicircular canals, of which there are three, and then there are the vestibular nerve and the auditory nerve that are attached to the cochlea. The oval window that is at the connection between the stirrup and the cochlea is how the energy enters the inner ear. The cochlea itself has hair cells in it. I just spoke about that in the last slide. And it's the job of the cochlea to change the mechanical energy into electrical energy and send that message that is then interpreted by the brain. It's important that we understand how this process works so that we understand the impact to disease and damage on the development of speech and hearing. So let's talk about the parts. Let's go back out to the outer ear again. Let's say there's damage there. Well, often maybe you think of swimmer's ear. And what happens there is infection, swelling, pain. So perhaps the gathering of information, the sound, isn't as effective. When there's damage to the middle ear, such as an ear infection, the cavity, the tympanic cavity, is often filled with fluid, inflamed. That makes the bones of the middle ear not move as well. When they can't move as well, they don't transport sound as efficiently. It's a little bit like talking underwater if you think of it that way. Sometimes the infection is so significant it perforates the tympanic membrane, so there's a hole in the tympanic membrane there again, not allowing it to vibrate in the way it was supposed to. The damage here is often transitory, meaning that once the infection heals, sound is able to transfer quite readily. Damage to the inner ear is not so easily repaired. Damage to this is often the result of loud noises or frequent exposure to loud noises. Unlike damage to the outer and inner ear, this is painless, but it can cause permanent hearing loss. It's important to realize that in order for normal speech and language to develop, it is a requirement that one would have an intact hearing system. Tonight, and I look forward to seeing your knowledge grow as you learn more about the hearing mechanism.